This highway wasn't built around the mountain. It was carved directly into it by 13 villagers with hammers. The Chinese government said it was impossible, too dangerous, too expensive, too remote. So the villagers ignored the government and built it anyway. 5 years, 13 men, 4,000 hammers, and a cliff face harder than anything engineers thought human hands could cut through. This is the story of how China's most advanced mountain highway techniques were discovered, not in a laboratory, but by accident halfway up a vertical rock wall when a group of farmers ran out of rope. In this video, you're going to see the full process, how China carved highways into sheer vertical cliffs, the tools, the physics, and the techniques that even modern engineers still call reckless. Well, you'll see why the government's own highway design was quietly abandoned halfway through construction, and why the villagers' version actually worked when the engineers' version couldn't. You'll find out what those 35 windows cut into the cliff face were actually for, because it wasn't what anyone planned. And there is one decision made during construction, something no one designed, something that happened by mistake, that permanently changed the way China builds through mountains today. We'll get to that at the end. But first, you need to understand where this began. Guoliang Village, Henan Province, China. Taihang Mountain Range. For over 1,000 years, this village existed in near total isolation, sealed inside a ring of cliffs so steep, so sheer, that outsiders simply never came. The only way in or out was a set of ancient stone steps, hand-carved into the cliff face centuries ago, 1 meter wide, 2,000 steps, more than 10 miles around the mountain. If you were sick, you climbed those steps to reach a doctor. If you needed food, you climbed. If you needed to sell anything, buy anything, connect to the outside world in any way, you climbed. In 1972, the village chief, a man named Shen Mingchen, had had enough. He petitioned the government for a proper road, a real road, something wide enough for a cart, something that didn't kill elderly villagers trying to carry grain down a 10-mile staircase cut into a cliff. The government said no. No road budget for a remote mountain village. So Shen Mingchen went home, called a village meeting, and proposed something that, by any rational measure, should have been impossible. They would build the road themselves. 13 volunteers. No construction experience, no machinery, no government support. They sold their livestock to raise 80,000 yuan for materials, and they began. Now, here is the detail that matters most at this stage. The cliff they were cutting into was sedimentary sandstone. Hardness, grade 8.2. For context, most modern industrial drilling equipment is rated to handle grade 7. Beyond that, drill bits wear out too fast to be economically viable. These men had hammers and chisels and rope. They started anyway. The method was brutal and simple. Workers were suspended on ropes from the cliff top, dangling hundreds of meters above the valley floor. They drilled blast holes into the rock face by hand, packed in explosives. They hauled themselves up, detonated, descended again, and cleared the debris by hand. Average daily progress, half a meter. Half a meter of tunnel per day, through grade 8.2 sandstone. At that rate, the tunnel would take 24 years. But it didn't. Something changed, and it started with a mistake. Before we get to that mistake, pause for a moment and consider what this looks like in 2022. Because China is still doing this. The Lujianlong Expressway, completed in 2022, crosses the Huajiang Grand Canyon on a steel truss bridge that sits 625 meters above the Beipanjiang River. The bridge structure alone weighs the same as 3 Eiffel Towers stacked on top of each other, It was assembled in 2 months. It cut travel time across that canyon from 3 hours to 90 minutes. Same country, on same mountain ranges, same basic problem. How do you cross ground that geography says you cannot cross? 50 years apart. The difference between those two stories, between 13 farmers with hammers and a 3 Eiffel Tower steel bridge assembled in 60 days, is exactly what this video is about. Back to 1972. 6 months into construction, the workers hit a structural problem. The tunnel was being cut straight, a direct horizontal bore through the cliff face. But the further they went, the more the inner rock wall began showing stress fractures. The sedimentary layers were flexing under the pressure of the blasting. If they continued straight, the tunnel risked collapse. The government's original plan, the one that was abandoned, had anticipated this. Their design called for a conventional mountain road, built along the outer cliff surface, not through it. Steel supports anchored into the rock, road surface laid on top. They stopped that plan because the outer slope was too unstable. Any surface road would erode and collapse within years. The rock simply wouldn't hold it. The villagers had no choice but to keep going inward, through the mountain, not around it. And then the 35 windows. As they pushed deeper into the cliff, the workers punched openings through the outer rock wall, roughly every 10 meters. The reason was practical. They needed to shovel debris out faster. The tunnel was filling up with broken sandstone. The windows were just holes. Nobody thought about what those holes would eventually mean. Now, by 1974, 2 years in, the crew had cut roughly 400 meters of tunnel. They were making progress, but the stress fractures were getting worse in certain sections, and at one point, in one critical stretch of wall, a work team ran out of rope. They couldn't continue in the direction they were going, so they drilled sideways. The government's abandoned design. Let's close that loop first. The original plan failed because sedimentary rock at surface level is under constant erosion pressure. Rain, frost, temperature shifts. Any road structure built on the outer cliff face would be fighting those forces every single season. Within 5 to 10 years, it would require constant expensive repair or collapse entirely. The villagers' instinct to go through the rock, not along it, turned out to be the only structurally sound solution. Interior sedimentary rock, protected from weathering, is dramatically more stable than surface rock. Government engineers missed that. 13 farmers figured it out. Now, those 35 windows. When the Guoliang Tunnel finally opened in 1977, those debris clearance holes transformed the entire character of the tunnel. A natural light poured in. The canyon views from inside the cliff were extraordinary. Framed by rough-cut stone openings, hundreds of meters above the valley floor, the tunnel felt less like a road and more like a gallery carved into a mountain. In 1979, a Japanese film company discovered it. They called it the ninth wonder of the modern world. Tourism followed. A village that had spent 1,000 years in isolation began receiving visitors from across the world. The windows that existed purely to shovel out rubble became the defining architectural feature of one of China's most photographed locations. When Chinese engineers later began studying how the Guoliang Tunnel had been built for documentation purposes, because they couldn't quite believe it had survived, they made an important discovery about the sandstone. Continuous drilling destroyed bits too fast to be viable, but blast and clear cycles, short controlled detonations followed by manual clearing, worked with the rock's natural fracture patterns instead of against them. That cycle method is now the foundation of China's rapid tunnel construction technique for hard rock mountain terrain. The engineers didn't develop it in a lab. 13 farmers developed it because they couldn't afford to keep replacing broken drill bits. But here is what is strange. When researchers cataloged all 7 hanging wall highways across the Taihang mountain range. Studying the construction logs in detail, they found something in the Guoliang records that nobody had formally reported. A structural anomaly in the tunnel's geometry, something that by all conventional engineering logic should have been a critical weakness, but had instead become the reason the tunnel was still standing. That decision made by mistake in 1974, when a work team ran out of rope and drilled. Here is what actually happened. When they changed direction, forced sideways by the rope shortage, they created an unintentional curve inside the tunnel. Not a sharp turn, a gradual arc, an S shape embedded in the cliff face. It looked like an error. It looked like the kind of messy improvisation you do when you don't know what you're doing. But when structural engineers analyzed the Guoliang Tunnel decades later, that accidental curve was the reason the tunnel hadn't collapsed. A straight horizontal bore concentrates structural stress at 2 points, the entry and the exit. In unstable sedimentary rock under vertical cliff load, those concentration points become failure points over time. The S-curve distributed the load laterally across the entire length of the tunnel wall. The pressure was spread. The rock held. China's National Engineering Research Center now formally classifies a technique called distributed lateral load curves for soft mountain tunnel construction, recommended specifically for sedimentary and layered rock environments. The principle was not discovered in a research facility. It was discovered in 1974 by a work crew that ran out of rope on a cliff face in Henan province by accident. Took 13 farmers who were told no, built a tunnel that taught China's engineers something they did not know. So here is what we know. The Guoliang Tunnel opened in 1977. It still stands today. It has been called the ninth wonder of the modern world, and it was built with 4,000 hammers, 12 tons of steel, and 80,000 yuan raised by selling livestock. The techniques developed by those 13 villagers, the blast and clear cycle, the lateral load curve, the interior bore instead of the surface road, became foundational to how China builds through mountains at scale. China now has over 40,000 kilometers of expressway, more than any country on Earth. And the question nobody has cleanly answered yet: how many of those routes use engineering principles that were never formally designed? We're covering that next. Hit subscribe so you don't miss it. And drop in the comments. Do you think the government should have built this road in 1972? Or did China actually need the villagers to figure it out first? I will see you in the next one.